The $1.5 trillion bet. Now, the Tesla Model S didn't end because of poor sales. It ended because of a number, 34 newtons per kilogram. Now, earlier this week, the news cycle was flooded with the honorable discharge of the Model S and Model X lines at Fremont. Now, for a decade, these were the crown jewels of the EV revolution. But in the cold logic of the humanoid economy, a car that sells 50,000 units a year is an engineering bottleneck. All right. Now, Elon Musk is currently ripping out the assembly lines that define Tesla's history to make room for a target of 1 million Optimus units annually. This isn't just a product shuffle, it is a complete reallocation of factory floor space from legacy premium EVs towards a robotics throughput bet. If you want to understand the future of this company, you have to stop looking at the car chassis and start looking at the actuary density. Now, today, we're breaking down the supply chain leaks that prove why this pivot is happening now and why the battery chemistry inside the Optimus just changed the game. The LG pivot solving the torso problem. Now, the biggest technical leak this week comes from the battery sector. Reports confirm that LG Energy Solutions is in the final stage negotiations to supply high-density ternary lithium batteries for Optimus Gen 3. To the casual observer, this looks like Tesla just outsourcing a component, right? To an engineer, this is a massive admission of physical limit. Now, for years, Tesla has touted the 4,680 cell as the future of everything, also known as the 4680. But the 4680 was designed for a car floorboard, a massive horizontal space where you spread weight out to maintain a low center of gravity. Now, a humanoid robot has a torso problem. You have a tiny internal volume that the volume has to house the compute, the cooling, and the power. If you use standard LFP or even current Gen 4680 cells, the robot becomes top heavy. It loses its bipedal balance the moment it tries to lift a 20 kilogram load. Now, LG's ternary lithium cells offer a significantly higher kilogram of energy density than anything currently coming off Tesla's internal lines. But pivoting towards LG, Tesla is sacrificing its vertical integration's ego to solve the energy to weight ratio. They need a battery that can sustain a 4-hour high torque work cycle without making a robot weigh 300 pounds. This is about physics, not just about supply. Now, the muscle, Suan, and the actuary paper trail. If the battery is the lungs, the actuators are the muscle. While Tesla claims to be a Texas-based company, AI company, the physical reality of the supply chain tells a different story. Now, recent 2026 data shows massive purchase orders estimated at over $685 million placed with Chinese tier 1 suppliers like Sanhua, Intelligent Control, and Generic Harmonic. I hope I'm saying that right. Now, these aren't just orders for parts, they are orders for integrated drive units. And Optimus Gen 3 utilizes 28 structural actuators for its body and 22 degrees of freedom in its hand. In previous generations, Tesla relied on off-the-shelf components, but the scale they're aiming for at Fremont requires custom-spec harmonic reducers and linear actuators that can deliver 180 Newton meters of torque while weighing less than a gallon of milk. Now, the tech first takeaway here is the China dependency risk. While the AI brain and the growth integration are handled domestically, the precision motion ecosystem, the gear sets and the rare earth magnets is still heavily centered in Asia. As Fremont converts its Model S lines, the success of the ramp depends entirely on Tier 1 suppliers hitting their yield targets. For the integrated drive unit without 28 joints, Optimus is just an expensive mannequin. Now, the factory math. So let's break down the one car versus 30 robots. Now, let's look at the industrial economics. Why kill a $90,000 Model S for $20,000 robot? It's a question of floor space productivity. Now, the square footage required to assemble one Model S with its thousands of fasteners, massive glass panels, and heavy subframes can be reconfigured to produce 30 Optimus units in the same amount of time. Now, Tesla is currently rebuilding a terafab for AI silicon and high density actuators by ending the S and X lines. They are freeing up nearly 20% of the Fremont footprint. In a world where labor is becoming a service, 30 robots generating labor ROI for external customers is worth infinitely more than one luxury sedan sitting in a driveway. Now, we are also seeing the first ever annual revenue decline for Tesla's automotive division this year. This honorable discharge of the legacy cars isn't an act of strength, it's an act of survival. Tesla is burning the boats. They are forcing their investors to stop valuing them as a car company and start valuing them as a robotics foundry. Now, the geopolitics in motion. The Monday brief is clear. The supply chain for the humanoid economy is finally detaching from the automotive supply chain. Now, when you see the Fremont factory line sitting idle next quarter, don't think failure, think retooling. We are watching the birth of a new magnet demand vertical. The Indy Fab paramagnetic magnetics, once used for Model S motors, are now diverted into 28 individual robot joints. Okay. Now, the pivot to the LG batteries proves that performance is now the priority over cost. The massive Sanhua orders prove that muscle is ready for mass production, and the death of the Model S proves that Tesla is no longer a car company. So, this humanoid systems analyst here, we'll be back tomorrow for the next report, and we'll look at why the Boston Dynamics just to put the Atlas production version into the humanoid factor and what that means for the Optimus timeline. So hit the subscribe to stay on the engineering side of the hype, and I'll see you in the next one.